Hey everyone, welcome to AIM396, where we're going to talk about how to integrate open source frameworks with Amazon Bedrock AgentCore. My name is Shreyas Subramanian. I'm a principal data scientist at AWS. I also have Aris, who's a senior GenAI specialist SA at AWS, and we're happy to also share the stage with Keith, who's a VP at engineering at Cohere Health. So before we get started, quick show of hands. How many of you have built an agent with either a no-code tool or low-code or an open-source framework? Quite a lot of us, yeah. And so you might recognize some of the frameworks up here and also the protocols. So building a basic agent requires piecing together all of these different complex components, right? So you have picking a framework, picking what tools to integrate with. You also have state management. But fortunately, some of these open-source frameworks came first, and it really simplifies the way you can build these agents. We also have open protocols like MCP and A2A that help with connecting agents to agents or agents to tools. We have open protocols and standards like OAuth for authorization. We have otel for observability, and all of these help you start off really quickly and build a POC. But going from POC to production is a totally different ballgame, right? So at AWS, since its inception, we've been contributing to open source, and we're proud to do that. We think open source is good for everyone. We've been contributing to Linux Foundation, to open source projects on GitHub. We're in the agents related talk, so we contribute to Strands, which is our own Agentic framework and also with other open source frameworks. We believe open source is good for everyone. We're committed to bringing this via managed services to our customers. And you'll hear from Keith at Cohere Health and on more about this as well. So today we'll be talking about specifically how AgentCore works with open source frameworks. If you haven't been in other AgentCore sessions, so AgentCore is our end-to-end agentic platform that helps you build and operate agents at scale. And so zooming out, a 30,000-foot view of AgentCore, if you look at all of these components that you see on your screen, AgentCore is comprised of all of these individual services. You can pick and choose what you want. In the center of your screen is AgentCore runtime. So with runtime, you can deploy any open source agent as well as MCP servers and A2A servers with no changes in code or minimal changes in code. These runtime agents run in a session-isolated environment. It can be a back and forth agent where you have a conversational interface, or you have a long-running agent that can run for hours and hours, like a deep research agent, right? Runtime also integrates with all of these other AgentCore services. So for example, runtime integrates with Identity, which is our Agentic identity and credential management service. It also integrates with Memory, which is one of the first enterprise-grade memory capabilities that you can have zero infrastructure setup, but you have short-term and long-term memory that can attach to your agents. We also recently introduced policy and evals in AgentCore, so this helps you constrain and also judge how well your agents are doing in production. What connects all of these different services together is observability, or AgentCore observability, which works on the OpenTelemetry or otel format. The nice thing with AgentCore, as I said, was you can pick and choose whatever services you want and to build your agentic application. And today we'll see different flavors of observability, for example. So Keith will talk about Arise and how they use that in production. Aris will talk about how we can use LangFuse with AgentCore as well. So before we get into the details, let's start with a really basic scenario, right? So let's say you have your customers, you want to track an order, and you're usually contacting customer service, and this customer service representative might have to look into like order management system or an external shipping provider API, or maybe even call them to get order status, right? They might also have to work with other technical support, human resources. So you have two teams working together to actually get your final answer. Which a lot of times is, have you tried restarting it? So, after all of that effort, you might get back an answer in a couple of days. We're going to try and replace these two humans or human resources teams out there with agents, right? So you have a customer service agent and a technical support agent. Now, these agents may not replace the entire functionality or the jobs to be done of these persons. It might just have to do a partial job, or it might be a co-pilot that's domain specific as well. So how do you get started? The first gut reaction we have is to look into open source frameworks, because open source frameworks have deep and wide integrations and community support, and we have great examples that you can start off with, right? So our gut reaction is usually there. But how do you pick which framework you have to start with? There are a lot of different factors, including how your team is working with certain frameworks already. But we're listing 3 top frameworks in our mind at least, so LangGraph, CrewAI, and Strands agents. And we're just listing a few factors that you can choose your Agentic frameworks with. So LangGraph offers a graph-based execution with extensive open source integrations. So it's powerful, but then it has a really steep learning curve compared to some of the other frameworks. So it's still good for complex agent orchestration with strong community support. CrewAI, on the other hand, is really easy to get started with, and especially for role-based and team-based agents where you're running a multi-agent crew, this is the best place to start. With Strands, which is our own open source agentic framework, we provide like a model-based approach, and it has access to local as well as AgentCore memory, for example. And this is ideal for a starting point for enterprise-grade agentic applications that's running on AWS, right? So you have all of these choices. You might have many more. We, in fact, have many applications and use cases that we have put in our GitHub repository that you can check out. But the good thing is you can pick and choose the frameworks for the right job, right? So in this case, we're picking Strands for the customer service agent and LangGraph for the technical support agent. You don't have to choose 2 different frameworks. You can choose the same framework as well. But in this case, as an example, we're saying we're choosing Strands for customer support and LangGraph for technical support. So what's the best way to get started with that, right? So you have, let's say, a Strands customer support agent that's running locally on your laptop. You have local credentials in there. The credentials let you access APIs that are hosted in AWS. And these AWS APIs, you can access because you have local credentials. The technical support agent, you're doing some hard integration between the Strands support agent and technical support agent. And what you also see is that the customer support agent has an API key that may integrate with an external service provider. But you can quickly notice that this is not going to scale, right? So this is running on your laptop. It's not something that you can host and you can have multiple users interact with. But your goal is to put this out for tens of thousands of users to use. So how do you do that? That's where AgentCore runtime comes in. And we spoke about AgentCore runtime a little bit. This is where we mentioned LangGraph, Strands, and other agentic frameworks. You can very easily host these agents, and you get a dedicated endpoint. These endpoints scale automatically based on your requests, and you can go from 0 to production really quickly, right? You can also connect these agents to any model provider, so it doesn't have to be Bedrock. It can be OpenAI, it can be any model provider pretty much. And you can also work with really strict security guidelines, so it could be a VPC-only mode, or you can only use OAuth. We also introduced resource-based access policies recently. Today, we also launched full support for the MCP spec, so if you have an MCP server, you can go and host your MCP server without any change in code. Also, bidirectional streaming was launched recently, which is useful for something like our customer service agent, right? So you're doing, right now we're imagining a text-based interface, but imagine you want to convert that to a voice-based interface. You can very easily do that with runtime, because runtime now supports bidirectional streaming. All right. So how do you actually host these 2 agents? We said there's a customer support agent and this LangGraph agent. How do you host that on runtime? There's 2 main methods to do that. You can either package up your code in a Docker container. That Docker container gets pushed to an ECR repository, and that ECR repository can be used as the starting point for deploying to runtime. The other, even easier way is you can zip up your deployments in a zip file, and you can push that to a S3 bucket, and then that S3 bucket becomes a starting point for your deployments in runtime. So there's two different methods. And to do this, you have to actually make a few lines of code change, right? And this basically says, make the right imports from the Bedrock AgentCore SDK, initialize this app, which is actually a starlet app, And then you have a decorator. It's an easy decorator. It says at app.entryPoint. It just points to this handler or this entry point as the starting point for your agent execution. What happens inside that my agent function that you see, it's completely up to you. To be any agent, any framework that you're integrating with, any business logic, and then finally you return a response. What you expect to work is, whether it's sync or async responses or if it's streaming responses, all of those should work, as though it was running locally. And this will with runtime, right? So now that you've made those little changes in your code, the next step is actually to use our Bedrock AgentCore starter toolkit. This is a really simple way to go from a code that exists locally to code that can be deployed. Now you have 3 steps. The first step is to do AgentCore configure. So AgentCore configure will basically set up your things like ECR repository that you want to land in, your role, whether you want IAM or OAuth. All of that just sits in a config file that's local. You can go back in and edit it on your own as well, but easy to manage it with AgentCore. The AgentCore CLI also has this next step, which is deploy. So you can do AgentCore deploy, which will deploy it to runtime, depending on those 2 choices that if you recall from the previous slide. So you have either the container version or the zip deployment version. And finally, within a minute, it'll be deployed, and you can start invoking your agent. All of the scaling and infrastructure management, all of that is happily managed behind the scenes, and you don't have to worry about it. Once you've launched that agent, of course, you can start invoking it. And in this case, we're saying, okay, we're going to use 2 different runtimes, one for the Strands agent, one for the LangGraph agent. There are use cases where you want both to coexist, but in this case, we're saying you can have 2 different containers that are running up for you. Everything else remains the same, meaning the AgentCore runtime has an execution role. It lets you access AWS APIs. You can use identity to store secret credentials, and that can be an API key, for example, for your external shipping provider. So if you want to track a shipment through their API, for example. But if you notice the integration between these containers and the API, as well as from the one container to another container, is something that you manage, right? So before we dive in even deeper there, let's talk about context engineering for agents. This is, you might have heard about context engineering and prompt engineering earlier. But when applied to agent, if we zoom into one of those agents, so either the Strands one or the LangGraph one, we can see that the context that you provide to that agent is extremely important, right? So you can have user instructions, you can have system instructions, you have retrieved information from RAG systems, for example. You might have short-term memory coming in with previous conversations, and you might have external or internal tools that are giving you additional context. So imagine if your tool gives you, a wrong context or a wrong response, or worse, if you call the wrong tool, if the LLM calls the wrong tool on your behalf, that still remains in your context for the agent, and your agent is going to respond based on that. So how can we make sure that all of this is handled, but we don't have to actually handle the integration points, right? So you as the developer are basically responsible for connecting those different nodes, right? So you have the customer service agent, which is Strands. You're writing integration code to connect to your order management system, writing separate integration code to do an API call. And then when you're connecting from one agent to another agent, you're also writing another integration code. So quickly, your integration code becomes the bulk load of your entire code base, right? You're not focusing on your business logic, but it's all of this integration code. But what if you could use some of these open protocols to help you out there? So one of the things that you've already probably heard about is MCP. MCP allows you to securely access external data and tools through a common interface. So there are 2 connection points to MCP within AgentCore. One, if you host your own MCP servers, or you have the code for your MCP servers, you can host that on runtime with no changes in code, and literally no changes in code. If you have external APIs or Smithy models that connect to internal AWS tools, or even an API gateway setup that you want to connect an MCP you can use Gateway for that. So AgentCore Gateway helps you create an MCP interface to all of your existing APIs. So there's 2 ways you can take AgentCore components and then connect it back to MCP. So that's from your agent to tools, right? So what about agent to agent? So as the name suggests, A to A is standardizing the interface when you want agents to talk to each other, right? So it was originally developed by Google, but then it was donated to the Linux Foundation soon after. So agents may be built with different frameworks, different languages, different models, and might be coming in from different providers as well. But you still want them to talk to each other natively. And so on the right, we're just showing an example of 3 different agents talking to each other with A2A. Since A2A is a native protocol like MCP that's supported in runtime, once again, you don't have to do any changes in code, and you can directly host your A2A servers. You can have an A2A client similar to a MCP client connect to these A2A servers to test it out as well. So great. So now we're going to change that little architecture diagram a little bit. So you have a customer service agent that's connected through the blue line, which is A2A, to another LangGraph's technical support agent. The red lines are now MCP. So that's a standard interface to go from the Strands agent to an order management API, which is, by the way, an internal AWS setup that you have. It also has another connection to an external shipping provider API. So Gateway, for example, if you have an open API spec for your external shipping provider API, you can import that into an MCP gateway. What we also have is deeper open source integrations into some of these AgentCore components from the frameworks itself. So we're constantly, pumping back some of this development back into the open source frameworks. One of the things that you can do, you can have the Strands a customer service agent use the built-in session manager, and you can add AgentCore memory to it. So both short-term memory, which is STM on the slide there, and then long-term memory as well. Similarly, in LangGraph, we have some deep integrations as well. So you can use what's called AgentCore Memory Saver, and what that does is you can save and load your checkpoints, and checkpoints store information like your user AI conversation or your graph execution state. And that can be loaded onto memory, and then once you restart your application with your Agentic container, you can rehydrate the container and restart where you left off. So we're excited to continue our partnership with LangGraph and LangChain, and all of us, our examples are based on some of these open source frameworks. For LangGraph specifically, we do this via the LangChain AWS library, so you can pip install LangChain AWS. This gives you all of the AWS LangGraph superpowers, like the one we saw earlier for the memory checkpointing, for example. With Strands, of course, this is our own homegrown Agentic SDK. But it also has 4,000 stars and 1 million downloads, and it's growing. Definitely check it out if you haven't already. It's easy to get started with, and we have a bunch of examples. We are the primary maintainers of Strands, but then it's a completely open source project. Lastly, the way we collaborate with some other frameworks like Crew AI is that we help make direct contributions to their repositories themselves. So Aris actually has a blog up there where you can scan and take a look at that. It's to build agentic systems with Crew AI and Amazon Bedrock. Separately, I helped Llama Index, with their RAG implementations and also integrations into AgentCore. So we're happily continuing to do this over and over again. So let's get back to our application at the end. So now you have AgentCore runtime that is used to run your customer service agent and your LangGraph technical support agent. You have A2A being the interface between those two agents, right? Then you have memory resources that are attached to each agent. There's also another alternative. You could have the two agents have a common memory resource as well if that's the way your application is set up. But in this case, imagine you have two separate memory resources for the customer support agent and the technical support agent. And then finally, you have a gateway that connects to the external tools as well. With that, we'll have Aris come up and talk about how engineering teams are transitioning from traditional DevOps to what we're calling AgentOps. Aris.
Thanks, Shreyas. So now that we have learned how we can build powerful agents with AWS services like AgentCore and the open source, and about the powerful integrations between these two, we want to take it one step further and think about how we can put that into production with operational excellence, obviously, right? So in the next 20 minutes, I want to talk about a couple of things that we have worked on in the last months, together with some major players in the open source space here as well. And I want to start with operational excellence. If you think about operational excellence in traditional software engineering, probably everyone would say DevOps is really a thing here, right? And we would probably also agree that DevOps is not one-dimensional. DevOps has a lot of different dimensions that we really want to get right if we want to be good in that field. Starting from infrastructure, we need to manage our infrastructure from top to the bottom. We need to pick the right tools with a lot of automation. And then we are all people. We are an engineering community, and we work in processes, embracing a specific culture. Now, in the first days of DevOps, all of these things were really not easy because we had a cloud, but we didn't have a lot of managed services, right? We didn't have that set of comprehensive tooling that we have today, and we hadn't yet agreed on a new common culture. A lot of the things were still very waterfall-like, so engineers really had a hard time. And we at AWS have pioneered that in the last decade. A lot of organizations out there and also the open source space have been inventing a lot of cool things over the past 10, 15 years here, right? So we at AWS, we launched powerful services like Lambda, like EKS, like S3, like CloudWatch, many more services that make all of our lives easier. We have entire companies that have raised out of the open source space, if you think about GitHub or Docker. And then we all as a community have embraced a new way of doing software engineering that is super agile with a lot of automation, with CI/CD, which is actually benefiting us a lot, right? So what I want to talk about today is how can we take what's working well in traditional software engineering and kind of evolve it into the agentic era that is starting now with all the new functional and non-functional requirements that are arising. And I want to do that sequentially, one pillar after the other, before bringing it together at the end. Starting with infrastructure, as I said, we have been pioneering that field for traditional software engineering with services like Lambda, S3, and many more. And we haven't started reinventing on your behalf. Shreyas has mentioned a service that we have launched in July at New York Summit, AgentCore, really specialized for agentic workloads. I'm not going to spend a lot of time. Once again, you have heard a lot from Shreyas. You have heard probably a lot about this service in the past days. But it is really absolutely useful in this specific scenario because it is a serverless service. It spins up agents quickly. There's a lot of things that the service is basically managing for you. So we strongly recommend using a service like AgentCore. And you will see how you benefit from it down the line as we go through the other pillars sequentially. Moving on to tools. Tools is actually a pretty vibrant space, or has been a pretty vibrant space in the last 1 to 2 years. A lot of stuff that organizations have built. We have built a lot of tooling within Bedrock, but also AgentCore. If you think about observability, the primitive or evaluations that we have launched here at re:Invent. But also the open source space and the startup space was pretty vibrant. So I was working with a lot of those startups across or alongside the last 1 to 2 years. The Y Combinator cohorts were full of those, and a lot of great tooling has been popping up. Since this is kind of an ecosystem open source session, we're going to focus on that space today. And as Shreyas has already said, I'm going to focus on Langfuse, which is one of the largest open source providers for observability, for agent ops as well. I've been collaborating strongly with those folks in the last months to develop the approach that we're going to be presenting. But again, whether proprietary or open source, you can really pick and choose because everything is built upon open standards. And if you think about open standards, observability, operations, DevOps, agent ops, really one of the most important here is OpenTelemetry. What is OpenTelemetry? It's not a new thing. It's been around for years in traditional software engineering. But what we have done as community is really we have further developed it, again, to work with the new arising functional and non-functional requirements. It defines a set of semantic conventions, which you can see here on the right side. So we basically standardize how we are capturing the data points, the telemetry, in objects. And then we have also standardized the way how we actually collect them and ship them into so-called OpenTelemetry backends. So the way that works is we all use these open source frameworks. They are auto-instrumented. That means there is already code in there that is collecting those metrics automatically for you if you configure them right. There is standardized exporters that are being built by organizations or by the open source, which are exporting that data, streaming them to the backends, and these backends can be the platforms we have talked about. So our observability platform that is tightly integrated with CloudWatch, or third-party open source ones like LangFuse. Now, I want to spend a minute speaking about LangFuse to really make sure we are all on the same page. What is LangFuse? It's an open source LLM engineering platform that is one of those open telemetry backends. This means you can stream your traces, your telemetry there is being stored, and then on top of that, there's a rich set of features that you can leverage. So you have core observability, where you can actually look into in a visual way what's really happening in your agents. And then there is a lot of other features as well, like prompt and dataset management, evals, experiments, human annotation queues, many more things. And we're going to use a couple of those further down the line. So to come back to the solution architecture that Shreyas has been building up sequentially in this session, you might recognize we have removed a couple of components that are not necessarily crucial for agent ops. But what we really want to do is we want to use LangFuse, so we need to host it. It's open source under MIT license, so you can just host it in your AWS account if you want. There's a marketplace offering, or you choose the fully managed SaaS version of LangFuse called LangFuse Cloud. And this is also the one that you will find being used in the code repository we're going to share at the end of this session. Now you see two black lines here connecting AgentCore, runtime, and LangFuse basically. I want to focus on the top one because this is really the last thing we need to do before we are up and running. We need to actually configure how the streaming of the traces works at the end. It's not difficult, but it's just a couple of things we need to configure. We need to configure a couple of settings, like for example, which endpoint we're going to stream our telemetry to, and things like how we're going to authenticate against LangFuse. A good way to do that is through setting environment variables when we are deploying the agents in AgentCore. You can see that on the right side. And then on the left side, this is basically a boilerplate agent implementation in strands. For AgentCore, you will recognize a couple of things that Shreyas has shared before. All we really need to do is adding 2 lines of code. I unfortunately don't have a pointer here right now, but it's 2 lines of code where you are initializing an exporter, and this will pull the environment variables in, and then the configuration is being set up, and you will see traces flowing into LangFuse as you're using your agents. And this is how it looks like. You have a rich set of information like the timestamps, the input and output of your agent on a high level. You can see how many observation levels the agent was going through, so how many turns it was doing till it solved a problem, token counts, latency, like a lot of information, and then you can also zoom into the different traces. With the observation levels on the top left, again, we have a graph execution view. Can be useful for us humans, a visual way to see complex executions. And on the right side, you see the data points we have collected in that trace based on the semantic convention we have defined. All right, so now we have connected infrastructure and tooling. We know what's going on. The next question is obviously how can we build processes around that are leveraging this, that are kind of making our life easier towards production. And we were actually thinking a lot about what would be a good approach to start together with the LangFuse folks. And we started working backwards from DevOps, right? So we were thinking about what is working good in DevOps and how can we evolve it. And the first thing we actually realized was a crucial concept in DevOps is testing. DevOps doesn't work without testing. And the analogy, even though it's a bit more complicated to testing in GenAI and agents, is evaluation. So we were thinking about how does evaluation play a crucial role alongside the entire lifecycle of an agentic application. And we found a pretty cool illustration from Evidently that is actually showcasing that. And we usually start kind of in a mode where we are trying to figure out a good implementation. So we are changing the code, maybe different frameworks, different models, prompts, sets of tools. And we want to figure out what works best, so we are running experiments, right? Based on some data sets that we have put together, and we are running evals on top of that. That is an iterative process, and at some point, we basically have a state that is, as we think, good enough to deploy into production. We deploy to production, we collect the traces, as we have seen earlier on, and then we enter kind of a phase of where we are thriving towards, first of all, operational excellence by moving into a more online way of running evals, building dashboards, creating automated alerts, for example, right? So this is operational excellence. We want our stuff to be running well. But then we also want to close the loop. We want to learn from what's happening in production, which means we can feedback learnings from production into our test data sets. If we realize that the data set distribution is not matching the distribution in production in reality. But we can also get inspired by what's happening in production to implement new things, right? So whether this is fixing bugs, fixing issues, or just the next best feature. All right, so the next step was really, we were thinking about, this is a great theoretical framework, but how can we make that a bit more tangible? A sequential process that we can start also then, or that we can also implement later on, right? And what we came up was this three-stage approach. We start with an experimentation HPO phase where we want to try out what's working well. Then we move further towards production where we have guardrails to production. Basically, we want to really make sure that everything is working. So we have a QA and testing phase, and we want to automate that. We want to do that with CI/CD because that's working really well in DevOps as well. And then we go into production, operational excellence, learning from working what's in production and closing the loop. Now, a lot of theory, going a bit more practical again, one step deeper. We have talked about, the process, the culture that we want to evolve. Now I want to come back to the infrastructure and tooling pillar to speak about how we can actually implement that. I want to start with infrastructure, then go over to tooling. But before I do that, we have two core assumptions that we are building all of that upon. And the first assumption is really that we strongly recommend to use a multi-environment setup. Different staging environments, dev, test, prod. It really makes sense. You don't want to experiment in your production environment and break the back end of your production application. Probably a lot of you have already implemented that. If not, we are strongly recommending it. And the second thing is maybe a controversial one for developers, but we strongly recommend end-to-end remote cloud-based development, especially when we have serverless services at hand. I know a lot of people like to develop locally, to get started for a POC locally, in notebooks maybe. And this is great, but as you mature in your org, as you have like a lot of teams doing that, a lot of use cases, you reach a point where it actually doesn't scale anymore. You have MCP tools that are remote that you're not owning, which you might not be able to access. And you really don't want your developers to spend weeks of development work just to realize that the stuff they have built is working on their local machine, but not in the target environment. So with those assumptions, moving further and getting started to the implementation. So first phase, experimentation, HPO. We want to figure out what's working well alongside a set of hyperparameters for implementations. But we don't want to do that by rule of thumb, just trying a couple of things out and seeing what works. We want to have solid data points. We want to have a proven methodology. So what we can do is actually, and automation concepts like infrastructure as code, but also the cloud, the fact that you can spin up agents in a matter of seconds with AgentCore comes really handy here. Is you can just go ahead and launch a fleet of agents. For example, one agent per hyperparameter combination. This is then a grid search in hyperparameter optimization. You spin them up, you run your evals, you tear them down again, super frugal way. You get your data points. You have tested out all combinations, and you have a solid data base, basically, that you can ground your decision based on. Then we move on. Once we have found the ideal setup, we push this in the code versioning repository, GitHub, code commit, whatever you want to use, this triggers an automated CI/CD pipeline that is here for QA and testing. It's going to deploy another ephemeral agent. Just one agent now. We run our tests. We get the results. If we are below the bar that we have set, we go back to the first phase. But let's assume we are good enough. Then we can deploy into production. Now it's a persistent agent that we want to use as backend for our production application. And we close the loop by learning from what's happening in production. So this is the infra side. Now, how does that look like on the tooling side? And I want to start with recognizing that all of these three phases are based on the concept of that we have traces available, right? Without the traces, we don't know what's going on in the agents. We basically need them. This is kind of the core assumption we are building the rest upon. Now, the first two phases are actually pretty similar in a way. We are running experiments of different sizes based on mainly offline evals with data sets that we have configured. Main difference is we might want to use different evals because we want to test other things in those phases. And then the size of the data sets can vary. If you think about it, in the first step, you have a fleet of agents. If you use a huge data set, it gets expensive. Now, in the second step, you have only one agent to test on, so you can maybe, with the same budget, do some more testing cycles. But this is really a trade-off we need to think through. And then in the second phase, we are basically transitioning a bit more into an online way of doing evals, even though async offline evals is also possible. And we might want to use a cool feature in Langfuse, the annotation feature, where we can actually have humans annotate traces and feed them back into our data sets. So to bring it all together, we have talked about how to actually evolve DevOps into something we might want to call agent ops, satisfying new requirements that have been popping up with powerful services like AgentCore that are integrating with third-party observability, agent ops tooling platforms out there. And we are really flexible because they integrate well. And we've also spoken about kind of a new culture with new processes that we are proposing here, and we hope you will all embrace in order to have a new era of successful software engineering now here in the agentic space. Now, before I close it up and hand over to Keith, I want to point out that we have a couple of resources for you. We have actually really built that. There is a code repository that you can fork and use as a starting point within your org. There's going to be some things that will be different to your orgs, but I think it's a pretty good starting point. And then if you want to dive deeper than what I could do now in 20 minutes, you might want to check out the YouTube video here on the right side. It's a deep dive that I have recorded with the CEO of Langfuse a couple of weeks ago. And with that, I want to hand over to Keith, who is VP Engineering at Cohere Health, and he's leveraging a lot of the things we have spoken about today with his teams and in their day-to-day work.
Thanks. Thanks, Ars. So at Cohere, we recently had the opportunity to partner with the AWS team on the beta and launch for AgentCore. And we built on top of it what we call Review Resolve, which is a product that we're using to help drive improved prior authorization processes. So for those of you who aren't familiar with prior authorization, in the US healthcare system, it's common practice where prior to a clinician performing a procedure, they need to make a request to a health insurance company to get that procedure approved. And the determination about whether or not that procedure can be approved is dependent on a policy. That policy can be defined by the insurance company. You have state-level policies. You have federal policies. In those policies, you've got medical necessity guidelines that have to be met prior to a procedure being approved. So, for example, you might have a knee injury. You're talking with your doctor, and she recommends that you get surgery for your knee. prior to performing surgery, she would have to submit a prior authorization request to the healthcare company. We would take a look at the policy. The policy might indicate, for example, as one part of the medical necessity criteria, prior to knee surgery, more conservative therapy has to have been attempted, like physical therapy, for example, over 2 months before you can get approval for knee surgery. So that example is like sort of a very kind of straightforward one. The reality is that the prior authorization process is a very complex one in healthcare in America. It has an estimated cost of about $35 billion annually. It creates an enormous amount of administrative overhead for clinicians, which reduces their time with patients. It also affects the timeliness with which patients get the appropriate treatment that they need. So at Cohere, we're really focused on helping clinicians and patients get to ES faster. And we do a lot of auto-decisioning. So based on the information that we receive in a prior authorization request, the clinical information that we have about a patient, and the policy that we're examining, in some cases, we can get up to 85% auto-approval rates. However, in that 15%, it needs to go to a clinician for review. We don't use machine learning or AI to ever deny a claim or deny a prior authorization request. But what we do use AI and agents is to help surface clinical information in that review process for the clinician to help them figure out whether or not medical necessity guidelines are being met and that procedure can be approved or not. This results in an uptick in like 30 to 40% faster reviews for clinicians, doctors, and nurses who are interacting with our review tools to make a determination on prior authorization cases. So I'm going to talk a little bit just about like the problem space here and some of the issues that we're solving with agents. So I think, typically if you're working with agents or language models, you're doing some sort of optimization between like latency cost and some accuracy measure. In this case for us, latency and cost aren't the primary factors. Precision and accuracy are paramount. We're making decisions that, or our clinicians are making decisions that determine whether or not a patient gets the appropriate care. We're looking through potentially, huge amounts of data for very precise information. The language here is like complex and specialized. Frontier languages, frontier models, state-of-the-art models do a reasonably good job of picking up on some of this. But there are like some complex problems here. So like lower back pain as an example. That might be expressed as lower back pain, low back pain, pain in the lower back, LBP, and everyone who's worked with language models or NLP is thinking like, well, that's a problem that's fairly easily solved to sort of semantically group those. The problem though is that in order for you to do that in a way that's effective, it needs to use like the same ontology and taxonomy that the policy is using, right? So term normalization, concept resolution, match up to the language in the policy. Or you're taking the policy and your clinical information and a third ontology and mapping and taxonomy and mapping everything to that. So this is a very complex space where just out-of-the-box language models aren't able to handle a number of these problems. Agent management is also complex. So we're dealing with both structured and unstructured data. So structured data might be claims history, for example. Unstructured data could be clinical records. There can be an enormous amount of either of those two. And I think that if you've done a lot of work with language models at this point, I think sort of intuitively, like based on precision and accuracy, you can sort of see that something like traditional like vector RAG search, similarity search isn't going to be particularly useful here. There are some times when it is useful, but you're not looking for something similar. You're looking for something that is a very precise match. So we need to do a lot of in-context learning with our models, so passing the structured and unstructured data in. We also need different representations of the data, so combining the structured and unstructured data into, say, a graph representation, and giving the agent options for how it might want to fetch that data to reason over is critical. There's also an important temporal component here. So I mentioned previously for the knee surgery, conservative therapy, you need to look at potentially clinical data or claims to see if hey, over the last 2 months, has the patient undergone physical therapy? You might be looking at blood values over time. You might be looking at very specific dosing information over a time window. And that kind of temporal data retrieval is something that language models typically don't handle very well. There's also a context window management problem here. You can easily overflow a context window with claims and clinical data. So how do you narrow down what it is you're looking for? What kind of heuristics can you use to determine what you pass to the model in context? And then the scope of your evaluations here expands rapidly. You're dealing with different data representations. You're dealing with a lot of data. You need a lot of ground truth data to run your evals against. This is very the complexity here grows rapidly. So I did want to talk. Obviously, this is an AgentCore session. Why we're using AgentCore. So as Shreyas and Iris have talked about, bring your own tooling is sort of a key principle here. We were already in the LangGraph and LangGraph and LangChain ecosystem, so we were able to fairly quickly move out of ECS into AgentCore. We're using Arise for telemetry, for observability. Iris was just talking about LangFuse, which is great. Arise has an open source product called Phoenix, which is also great. We do use Arise's enterprise edition, Arise DX, but it's a great, their open source Phoenix is a great point of comparison against LangFuse. And we also use LiteLLM for an LLM gateway. I'm not sure how many people here are using LLM gateways, and I'll talk about it a little bit on the next slide. And then, something that really appeals to us as a startup is, there's minimal to no infrastructure management here. And anytime my team's not managing hardware or infrastructure, they're focused on product development. We're in a regulated industry. The micro VM architecture, fast spin up, spin down, no shared memory is important for us. Shreyas brought up the CLI that fits really neatly into our existing CI/CD pipelines. And otel works really well, like I said, to hydrate, Arise. All of this works pretty seamlessly out of the box with minimal code changes. Two things that are really important for us is AgentCore gateway and governance and security, and I see them as very tied together. Let's say that we have a specialized subagent that is a claims-related subagent, so it's able to pull claims for a patient and search for data in claim history. And we might have an API that we have internally that allows has different endpoints to interact with claim information. What's nice is we can put AgentCore Gateway in front of it, but what's critical is that from not just a security by design perspective, but compliance by design, we need to know, okay, who's interacting with the main agent in a review session. If there's a call to a subagent to look at claims data, what's the identity of that user who made that claim, who made that call to the subagent? What are they authorized to see? And can we ensure that they only retrieve information for a patient that they have access to? This is critical for compliance and audit. Shreyas also mentioned short and long-term memory. So short-term memory supports text and binary data. He mentioned LangGraph checkpointing, which needs to use binary data. It's a very straightforward plugin from the AWS team to drop into LangGraph to get short-term memory storage. Long-term memory is more complicated, I think, regardless of the framework you're using. One thing that we found useful is namespaces for managing like a multi-tenant environment. You need to spend some time thinking about your memory architecture here. This is, I'd say, significantly more complex than short-term memory, especially if you have multiple agents. So I'm going to just talk about our architecture a bit here, and it is, yeah, I wish I had a pointer. It looks busy, but it's actually like the complexity of it is reduced, because I'm only showing one agent, which is in the reviews all platform, and like just in the middle it shows the chatbot supervisor. So that's that's running in LangGraph, and we're connecting to AgentCore short-term memory there. Like I said, very seamless integration. Within the chatbot itself this particular agent is running on AgentCore infrastructure on the micro VM. All of our traffic is running through Light LLM to Bedrock. So Light LLM is an AI gateway. If you haven't worked with one of these, it functions as sort of like a reverse proxy for talking to different model providers. It gives you really nice features like rate limiting, insight onto like token usage by user, cost controls. You can put common guardrails in place. We're mostly working with Bedrock, but it's seamless for us to pull in Gemini, anything from OpenAI, behind Light LLM. And if a client in front of Light LLM wants to use those, you're really just changing an API key in the name of a model. All the other work is being handled via the gateway. You can see on the left, we're using Arise prompt management. So, sorry. I'll talk about evals in a minute. For us, we tend to separate our prompts from like our application code so that we have a life cycle and a deployment life cycle, a life cycle and a deployment life cycle for prompts that's separate from code. You can make updates to prompts without having to redeploy containers. At the bottom, you can see indication level LLM prompts in the lower left there. So thinking about that claims agent for a moment, you might have this supervisor agent, and that's what the doctor or the nurse is interacting with. And you might make a call to a specialized sub-agent for claims. Something that I feel like we talk about a lot when we're talking about MCP is tools. I think how we use prompts in MCP is really interesting. I don't see like as much about it. Maybe I'm reading the wrong authors. But in this case, you could pass the medical necessity criteria to that claims agent. It could decide what claim history it wants to grab, and also select what is the medical necessity criteria or the indication level is the terminology we'd use. What prompt do I want to grab in order to look for this information in the claim history? So there's multiple ways we handle clinical data extraction, including like with fine-tuned models. But this is like particularly interesting, and it also adds to the complexity of your evals. It's a powerful methodology, but as your clinical areas grow, as the number of prompts you have grow, being able to evaluate whether or not you retrieved the right prompt and applied it in the right way for that sub-agent against that data to get the information you're looking for becomes another set of evaluations you have to run. The announcement about session level evals is really exciting. Being able to run evals across like the whole set of agentic interactions is really critical. And then I'm just going to touch on evals here briefly. It's my slide here is much busier than Iris's. So like I mentioned earlier, we're already in the Arise ecosystem. We have online evals, so from LangGraph and AgentCore, we have data going into Arise. That can get piped into our online evaluation. We could have a LLM as a judge there. looking at things like hallucination rate. We could be looking at guardrail violations. There's like a number of things that you might want to be looking at for online evals, and especially like if you wanted to determine if performance is changing in any way. We also hook into our offline evals here. We have clinicians on staff, doctors, nurses, subject matter experts. So we're able to have human annotators in the loop here, and that can all be fed into our offline evals process, where we're determining the effectiveness of a particular prompt, of a fine-tuned small language model, of the agentic system or the set of agentic calls as a whole. And just like with LangFuse, like we already had something like this, we're able to keep this mostly working as is and plug it into AgentCore and get all this data hydrated the way that we needed it to. That's it for me. I'm going to hand it back to Shreyas.
Thank you, Keith. And in summary, what we saw AgentCore that can integrate with multiple open source frameworks as well as protocols. Aris walked us through AgentOps as well as a deeper integration with LangFuse. And we saw a really exciting real-world application with Cohere Health as well. I'm going to leave this slide up there for you to scan. I know folks were trying to hurry up and scan quickly when we changed. So thank you so much for attending our session, and I hope you found this informative. We're going to hang out here for a little bit to take any questions later on. Thank you so much.